கார்லேஷன், ஆட்டோ கார்லேஷன், கிராஸ் கார்லேஷன் பற்றி நம்ம டிஸ்கஸ் பண்ணோம், போத் இன் கண்டினியூஸ் டொமைன் ஆஸ் வெல் அஸ் இன் தி டிஸ்க்ரீட் டொமைன். ஸோ அது நம்ம வெப் ரிசோர்ஸஸ் யூஸ் பண்ணி ஜஸ்ட் நம்ம டேட்டா ஃபீட் பண்ணி பார்த்தோம். கண்டினியூஸ் கேஸுக்கு வந்து நம்ம ஜஸ்ட் டயக்ராம் எடுத்து பார்த்தோம். என்ன நித்யகுமாரி எஸ் ஹேண்ட் ரைஸ் பண்ணுறீங்க? எஸ், ஓகே. ஸோ தேவையில்லாத பட்டன்ஸ்லாம் வந்து அழுத்தாதீங்க. எதனா கேட்குன்னா நீங்கள் மைக் ஆன் பண்ணி டைரெக்டாகவே கேட்கலாம். ஸோ இப்போது இந்த கிளாஸில் நம்ம யூஸ்வலாக ரேண்டம் ப்ராசஸ் வித் ரெஸ்பெக்ட் டு சப்ஜெக்ட், அதாவது அதனுடைய ஃபார்முலாஸ், அது ரிலேட்டட் ப்ராப்ளம் இதெல்லாம் வந்து சால்வ் பண்ண போகிறோம். ஸோ மோஸ்ட்லி இன்றைக்கி நம்ம கான்செப்ட் இதெல்லாம் மட்டும்தான் பார்க்க போகிறோம். நெக்ஸ்ட் கிளாஸில் நம்ம வந்து ப்ராப்ளம்ஸ், ப்ரீவியஸ் இயர் கேட் ப்ராப்ளம் அண்ட் அதர் எக்ஸாம் ப்ராப்ளம்ஸ் எடுத்து நம்ம வந்து சால்வ் பண்ணலாம். ஸோ பிஃபோர் நம்ம ரேண்டம் ப்ராசஸ்க்கு போகிறதுக்கு முன்னாடி ஜஸ்ட் வி வில் சி தி ரேண்டம் வேரியபிள்ஸ், அதுக்கான ஃபார்முலாஸ் இதெல்லாம் பார்த்துட்டு டைரெக்டாக நம்ம வந்து ரேண்டம் ப்ராசஸ் போகலாம். ரேண்டம் வேரியபிள், ரேண்டம் வேரியபிள். ஸோ ரேண்டம் வேரியபிள் இருக்கிற சம் ஆஃப் த பேசிக் ஃபார்முலாவும் வந்து நம்ம ரீகலெக்ட் பண்ணிக்கலாம். ஏன்னா இந்த ஃபார்முலா வந்து நம்ம கம்யூனிகேஷன் ரிலேட்டடாகவும் யூஸ் ஆகும், இல்லைன்னா மேத்தமெட்டிக்ஸ்ல இருந்தும் கொஸ்டின் வரும், மேக்ஸ் 4. ஸோ அதுக்கும் வந்து யூஸ் ஆகும். ஜஸ்ட் ஐ வில் ரீகலெக்ட் தி ஃபார்முலா. ஸோ PDF, okay, probability density function is equal to differentiation of CDF, a cumulative distribution function, or otherwise CDF, cumulative distribution function, is equal to integration of PDF, probability density function. Then for any given random variable, okay, minus infinity to plus infinite.
Screen share.
Yes. Okay. So for random variable, we know what is PDF, probability density function. That means probability value, actual probability value with respect to variable X, and then CDF, cumulative distribution function. So PDF is equal to differentiation of CDF, or CDF is equal to integration of PDF. And then for given function, okay, we will have the PDF, probability density function, for a given random variable. So that is f of integration f suffix capital X, then small x is equal to 1. That means total probability is always is equal to 1, whether we are in the continuous domain or in the discrete domain. So whenever we have integration formula, that means we are in the continuous domain. Then in the cumulative distribution function, say we will define cumulative distribution function in terms of capital F of X. So capital F of X, small x. In case of small x, if you put minus infinite, then answer is 0. Okay, then in case of small x, if you put infinite, then the answer is 1. And then we know that CDF, cumulative distribution function, characteristics is always it will increase monotonically. Okay, it increases. CDF will always increase monotonically. So it is always a increasing function, so it will never decrease. Okay, what is the idea here? It increases monotonically means it will never decrease, and also it may remain constant. So the main idea of this CDF is that is it always increases. That means it never decrease. The actual meaning of this is it never decrease, but it may remain constant. It may remain constant. This is one of the property of the CDF, okay, cumulative distribution function. So these are all the some of the basic formula with respect to the random variable and the probability density function, and then CDF function. So mainly we are having many variety of random process. That means probability density function. So a process may follow a Gaussian distribution or normal distribution or uniform distribution. So there are many distributions are available, but here we will see only few of that. So first one is normal distribution or Gaussian distribution. Gaussian distribution. Gaussian distribution. The formula, the probability density function for Gaussian distribution f of x is equal to 1 by sigma root of 2 pi e power minus 1 by 2 x minus mu by sigma whole square, x minus mu by sigma whole square. We know that mu is indicating the average value, sigma is the standard deviation, or sigma square means variance, okay. Then for this function, or in generalized variance, or otherwise, first we will draw the diagram of this one, Gaussian distribution function, or what is the another name for Gaussian distribution function, that is normal distribution function. Normal distribution. Another name for Gaussian distribution is normal distribution, because any normal phenomena will follow the Gaussian distribution. Say for example, in the class we are conducting the test, say the test score may be in between 0 to 100. Okay, if you plot the number of persons who have scored, actually how many number of people scored 100, how many number of people scored 0, similarly how many number of people scored 50, if you plot, actually it will follow the normal curve. Okay, see, if you conduct the test in the proper manner without revealing the question, and also by taking the question using the Bloom's taxonomy. Okay, Bloom's taxonomy means it consists of many levels, so that means question should not be too easy or too difficult. Okay, if you properly set the question paper, okay, then based on that, if you conduct the test, okay, once if you draw the graph for that, okay, the result for the graph, if you draw the result, if you draw the graph, actually it will follow the normal distribution. That means almost more number of people will score around 50, only very few people will score around 100, again very few people will score around 0. So usually it will follow the normal distribution or Gaussian distribution. Any natural phenomena usually will follow the Gaussian distribution, that is the another name, that's why it is also called as a normal distribution. Okay, then we know that some of the basic formula for variance, okay, that is a generalized formula. Say variance of x is equal to e of x square minus e of x whole square, minus e of x whole square. You know what is e of x square? It's like a second order moment. Okay, e of x square is the second order moment. E of x means mean value. Okay, mean value overall square. So for some cases, suppose for some process, if the average value is 0, again we can mention like variance of x is equal to e of x square, variance of x square. Okay, so what is the another generalized formula for variance of x? Okay, the generalized formula for variance of x is e of x minus mu whole square. E of x minus mu whole square is the generalized formula for variance calculation. For any given random variable, what is the variance? Okay, this is the main formula. Once if you expand this formula, then only finally you will be getting this formula, variance of x is equal to, after the simplification, from this you have to simplify, finally you will get this formula. These are all the generalized formula. This is true for any distribution. Okay, so but for this distribution, what is the average value? Mu is the average value for this distribution. Mu is the average value for this distribution. A standard sigma is the standard deviation, or sigma square is the variance. Then uniform distribution. In the uniform distribution, all the variable, all the numbers will have the same probability. Say if you are observing from A to B, okay, then it will follow the same value. So this is 1 by B minus A, because the area under the probability density function must be always 1. So that's why here in the y-axis we are putting 1 by B minus A. This is actually indicating the PDF, probability density function, okay, of x. So the definition f of x is equal to 1 by B minus A. Okay, 1 by B minus A. then what is the mean value for this one? Mean value of this one is simply a plus b divided by 2. A plus b divided by 2. Then what is the variance of this one? That is b minus a whole square divided by 2. B minus a whole square divided by 2. So again, by using the regular formula, you can calculate all this. Okay, first you have to calculate the mean, then variance. To calculate the variance, first of all, you should know what is e of x square. Then once you do the subtraction, then finally you'll get the variance. Okay, these are all the basics. Okay, so again, for any given distribution, we can also find out the nth moment. We can find out the nth moment. So nth moment of a particular probability density function is equal to integration of x power n f of x dx, f of x dx. So now you can observe, if you take the first order moment, if you take the first order moment, that is integration of x f of x dx, that is the actually the mean value. So okay, for any probability density function, if you take the first order moment, that will give the mean value. Okay, so similarly, if you take the second order moment, say integration x square, integration x square f of x dx, then it will give the e of x square. Okay, if you carefully observe, it will give the e of x square. So for in generalized nth moment means integration x power n f of x dx. So these are all the basics of the random variable. So now we'll enter into the random process. Okay, so random variable means what? Assigning the number, okay, real number for a event is called random variable. So what is the random variable? So already we know what is probability. Say for example, I am having a coin. So the sample space of this one is h comma t. Either I will, when I toss the coin, I will get either head or tail. Then if somebody is asking what is the probability of getting head, then I can say it is 1 by 2. But instead of this head, I will associate with some real number. Say this getting head, I can associate with some real number. So say I can mention like p of minus 1, that is 1 by 2. Similarly, what is the probability of getting tail? This tail I can associate with some other number, say plus 1. Some feedback is coming. Mic on manadanga. Yes, who is making the problem? Mic ellame off பண்ணிடுங்க. So I can associate. So that means what? The event. Okay, the event is mapped to already probability is there, but the event is mapped to the real number. Mapping of the event to the real number is called random variable. Then already probability will be there. Okay, either it is a head or you are putting some number, then it will have its own probability. So that means mapping of event into a real number is called random variable. So mapping of real number, mapping of each event in the sample space to a real number, mapping of each event in a sample space is called random variable, So already you know what is probability. So whenever the probability is there, that must be the event. Okay, so for that event we are assigning some number. Later you can understand why we are assigning numbers. For instead of telling head, why we are assigning numbers, later you'll understand that. Why? Because in real-time processes, mostly sometimes we will also discuss with the numbers. See, you can observe here in the x-axis we are having numbers. That's why we go for random variable. Okay, instead of the events, we go for the random variable. Then along with the random variable, if you are including the time, see, usually the random variable we will denote with capital X. A random variable we will denote with capital X. Okay, so if this random variable is function of time, then that we will call it as a random process. So random variable means what? Random variable with the function of time is called random process. So okay, random variable along with the function of time. So that means what? For particular event occurrence, the probability of occurrence of event again is going to be depending on the time. So that's that we will call it as a random process. So random process is equal to random variable with respect to time. So now I am having some sample space. In that I am having many events, say event A, B, C, D, like that. The first time I am picking the event A. Just from the entire sample space, I am picking some event. Again, what is the behavior of the event? See, this event is giving some value here. Again, it keeps on changing with respect to time. See, now I am observing only one event. That one event nature itself is varying with respect to time. Then next I will choose the another event, say B. Again, what is the behavior of the event? I'm just noting down here. Similarly, I will note down what is the behavior of each and every event. Here, this A, B, C, D is a particular event in the common sample space. This is the common sample space. Common sample space. From the common sample space, at any point of time, I'm choosing only one event. I am observing the nature of the event with respect to time. So this is actual behavior of the event. Okay, this is actual behavior of the event. Again, for that event also, you can draw again, you can draw the PDF like that. But here, just this is the nature of the event with respect to time. So different event is having different nature. Different event is having different nature, but all the event have been taken from the same sample space. All the event have been taken from the same sample space. That is the main idea here. Okay, so now next, here you can understand two things. One, see, at any point of time, I can go in the horizontal direction, or otherwise I can go vertically downwards. Say that means I am fixing some time, say at T1, I am observing what is the value, actual value from the different event. You can observe here at T1, I am getting this value. So that I am denoting like XA of, okay, XA of T1. It is like a number. It may see here, you can understand it's like some negative number, say 1.5. Okay, see, usually capital X is random, but at T1 it will have some value. That value I'm just mentioning here. Similarly, event B, but for that events also, I am observing on the same time at T1. Say it is having some value, say +1, and then XC at T1, say it is having some 1.5 like that. Again, XD at T1, it is having some other number, say -0.5. So now, at particular time, I am at same time, but observing nature of the different event. I'm observing nature of the different event. Okay. So if we take average for all these, I can take average for all these. Okay. Manually, you can do the average. Okay. 1.5, 1.5 cancel. 1 minus 0.5 is 0.5. 0.5 divided by 4. That means 0.125. Now you can take the average of these two. So if I take average in this manner, that average is called ensemble average. This averaging, okay, if you do the averaging like this average is called ensemble average. Very important. Okay, so that means what? From the sample space, I am observing different event with respect to the time. First of all, I am fixing the time. Then I am finding out what is the average. Okay, that concept is called ensemble average. Then what is the time average? Okay, when you do the time average, you have to choose any one of the event. Okay, say for example, I am choosing event C, and then I know what is the value, how it is varying. Okay, see, event C is varying like this. I am interested in finding average value for this event, say the complete event from 0 to up to sometime, say T, capital T. Okay, for the event C, I am going to calculate the average value. Okay, average value, say what is the overall time, T. I am observing from 0 to T. Then what is this value, XC of T, dt. Okay, so this average is called time average. Okay, very important definition. You should know clearly what is the difference between the time average and the ensemble average. Later, we'll tell if time average is equal to ensemble average, that particular random process is called ergodic random process. But at this point of time, just we are discussing about two different types of average, two different types of average. One is time average and another one is ensemble average. Time average means you have to fix the event, then vary the time, observe over entire time. Ensemble average means fix the time and observe the nature at the different event, then you do the average. Okay. So now these are all in terms of sample values. Okay, you do the average. Okay, in terms of discrete domain. In the discrete domain, then you'll get the ensemble average. But time averaging, you have to do it in the continuous domain. But in reality, you may not know what is the mathematical function of XC of T. That is different. But just we are defining the definition. Just we are discussing about the definition now. What is the time average or ensemble average? So next, we'll try to understand what is the correlation here. Here also we'll try to write the correlation function. Why? Because so now we'll discuss about the correlation function. So just now we have seen what is the average value, then what is the correlation. What is the correlation? Say at T1 I am observing the sample values. Similarly, I may fix T2 at some other point. T2 at some other point. Okay, there also I will draw the line. Okay, at some other point I am drawing the line. Then I am choosing the sample values. That means I am observing at T2 now. At T2 I am observing. Okay, so here exactly at T1 I am having four set of values. Okay, four set of values. I am having four set of values. I know what is the values. Similarly, at T2 I am having four set of values. I am having four set of values. So already I told you, whenever you have two set of data, you can calculate the correlation. You can calculate the correlation. Already formulas are there. Okay, just you can calculate the correlation. That means what is the correlation between this data set with another data set. Okay, so one thing you can observe, when you try to increase the difference between the T1 and T2, the correlation level, amount of correlation will decrease. Just with the common sense, with intuitive understanding, you can understand this. Okay, with the intuitive idea, you can easily understand why it is decreasing. See, or otherwise you can imagine like this. Say, for example, when T1 minus T2 is 0, that means the difference between these two is 0. That means what? T1 is equal to T2. Okay, so I am taking the data set, and also T1, T2 is same. Again, another data set is also I am taking at the same time. Then if you correlate, definitely there will be the high correlation. When the difference is very, very less, the correlation will be very, very more. The correlation will be very, very more. When the difference increases, correlation may decrease. Mostly it has to decrease, but it all depends on the nature of the signal. Sometimes it may increase also. It may, initially it may decrease, then it may increase, but usually it will decrease. So what I'm trying to say, tau is the difference between these two. When I am increasing the tau, the autocorrelation function, ACF autocorrelation function will decrease. Autocorrelation function will decrease. That is the concept of the autocorrelation. Why we are calling it as autocorrelation? Because we are discussing the behavior of the same sample space. All these events have been taken from the same sample space, but we are observing at just a different time. So that's why this is the autocorrelation. இது புரியுதா யாராவது ஒருத்தவங்களுக்கு? How I am telling autocorrelation is decreasing when you are increasing the difference T1 and T2. Anyone? இது புரியுதா இங்க என்ன சொல்ல வரேன்னு? யாரோ ஒருத்தவங்க? எஸ், எனிபடி? நான் என்ன சொல்ல வரேன்றது புரியுதா? Then I will move further. Anyone? Yes or no? Yes, okay. So இதுதான் autocorrelation. Next, what I'm going to do, see, now I have taken T1 minus T2 as some tau. Now I am going to fix some other time, say T3 and T4, but that time difference is also tau only. Okay, I am going to choose some other time, say T3 and T4. That means what? Instead of choosing here T1 and T2, now I am fixing T3 here, T4 here. But what is the observation? The difference is same. Now what is the autocorrelation function? I have taken two cases. Say this is the case 1, ACF case 1, ACF case 2. Okay, but I have fixed the difference is same. The difference between T3 and T4 is same. Then if both are both can be equal or may not be equal. Okay, we cannot say. It all depends on what is the nature of the randomness present in this sample space. Sometimes it may be equal or may not be equal. It may be equal or may not be equal. So if it is equal, it will come under some category. Okay, if it is not equal, then it comes under the other category. இது என்ன சொல்ல வரேன்னு புரியுதா? But definitely if you vary tau, okay, if tau is not if tau is different, definitely ACF will be different, no doubt, because by nature autocorrelation function is function of tau. But what I am telling, tau I am fixing same, but I am choosing different time interval. Instead of t1 and t2, I am choosing some other timing space, that is t3 and t4. So now what I am telling here, there are two possibilities. ACF may be equal or may not be equal. If it is equal, it comes under some category. Otherwise, it comes under the some other category. Okay, these are all the basics with respect to the random process. So now we will quickly move the formulas, regular formulas. தேவைப்படும் போது நம்ம இந்த டயக்ராம் ரெஃபர் பண்ணுவோம். அடுத்தடுத்து இருக்கிற